There is a world out there that looks almost nothing like the planet we call home. It has no oceans, no blue sky, no familiar seasons, and if you somehow stood on its surface, you wouldn't even recognize the sky above you. Because this planet isn't orbiting a normal star. It's orbiting the dead remains of a star, a pulsar, an object with roughly the mass of our sun compressed into something only about the size of a city, spinning almost 300 times every second. And somehow, there is a planet orbiting it. But that's only the beginning. James Webb looked into this planet's atmosphere and found something that has never been detected dominating an exoplanet atmosphere like this before: molecular carbon. Carbon molecules known as C2 and C3 appear to be present in an atmosphere dominated by helium and carbon, with almost no oxygen or nitrogen available for the carbon to bond with. The planet is also incredibly close to its dead star, only about 1 million miles away. Its entire year lasts just 7.8 hours, and the pulsar's gravity is literally stretching the planet into a strange, lemon-like shape. This is not another Earth. It isn't even remotely close. And that's exactly why scientists are so interested, because this bizarre world may be showing us something important. Planets can survive conditions far more extreme than anything our solar system has ever experienced. So, what happened to this planet? Why is its atmosphere so strange? And how did a world like this survive the death of its star? To understand that, we have to travel to one of the strangest planetary systems James Webb has ever observed. Our solar system feels familiar. The Sun sits at the center. Earth orbits at a comfortable distance. Jupiter is farther out. The planets follow relatively stable paths. It's easy to assume other planetary systems work in roughly the same way. But nature doesn't care about what feels familiar. PSRJ 2322-2650b proves it. This planet orbits a pulsar. A pulsar is the incredibly dense remnant left behind after a massive star dies. The star once burned through its nuclear fuel. Eventually, its core collapsed. Its outer layers were expelled, and what remained became an object with extraordinary density and gravity. The pulsar at the center of this system spins almost 300 times per second. Now imagine a planet orbiting that object, not millions of miles away, but only around 1 million miles from it. For comparison, Earth is roughly 100 million miles from the Sun. This planet is dramatically closer, so close that it completes one full orbit in just 7.8 hours. That means its entire year passes before a normal Earth day is over. And the pulsar's gravity is so intense that the planet is being stretched. Instead of looking like a perfect sphere, models indicate that it has a bizarre lemon-like shape. One side is pulled toward the pulsar, while the other side is stretched away. This is a world living under gravitational conditions that are completely alien to us. But somehow it has survived. And not only has it survived, it still has an atmosphere. That's where James Webb entered the story, because scientists wanted to know what this strange planet was actually made of. The answer turned out to be far more surprising than anyone expected. James Webb doesn't have to land on a planet to investigate its atmosphere. It can read the atmosphere through light. Every molecule interacts with light in a particular way. Certain wavelengths are absorbed, while others pass through. Together, these patterns create a chemical fingerprint. It's almost like a barcode. And when Webb examined PSRJ 2322-2650b, the barcode looked completely different from what astronomers expected. The atmosphere appears to be dominated by helium and carbon. But the most extraordinary clue was molecular carbon. C2 and C3 molecules made entirely from carbon atoms. NASA says that among roughly 150 planets whose atmospheres had been studied in this context, none had previously shown detectable molecular carbon. That is an astonishing result, because under the temperatures found on this planet, carbon normally wants to bond with other elements oxygen, nitrogen, and hydrogen. But apparently, there isn't much oxygen or nitrogen available, so carbon is left to bond with itself, and that creates an atmosphere unlike the atmospheres of Earth, Jupiter, Neptune, or any other familiar world. The temperatures make this even more extreme. The coldest regions can still reach roughly 1,200 degrees Fahrenheit. The hottest parts can reach around 3,700 degrees Fahrenheit. This isn't a world where liquid water oceans could exist. This isn't a world where life, as we know it, could comfortably survive. It's a world of extreme heat, extreme gravity, and extreme chemistry. And the atmosphere may contain something even more bizarre. Scientists think carbon-rich soot clouds could exist high in the atmosphere. Deeper down, where pressure and temperature become enormous, carbon could potentially condense into crystals. Diamonds. Imagine a planet orbiting a dead star with carbon clouds in its atmosphere and potentially diamond-forming conditions deep inside. It sounds like science fiction, but this isn't why the planet is truly mysterious. The biggest question is much harder. How did a planet like this form? Here's where the story becomes fascinating. The planet we see today may not be the planet that was originally born in this system. Its history could be completely different. Scientists know that the pulsar was once a massive star before it died. There may have been a very different planetary environment around it. The planet could have formed under conditions much more ordinary. Then the star reached the end of its life. Its core collapsed, its outer material was expelled, and the planetary system was transformed. But PSR J2322-2650b somehow remained. And after the star became a pulsar, the planet entered a completely different phase of its existence.